In this video, we're going to look at topic 65, example 3, where we write a piecewise defined rule from a graph. So it's kind of the opposite from the previous example. In example 2, they gave us the piecewise defined function and we had to come up with the graph. This time, they are giving us the graph and we have to come up with the piecewise defined function. First thing I want to point out, though, there is a small mistake here. At the end of this green portion of our graph, there should be a closed circle at 8, 8. So just make sure that you have that there. That will make a difference when we're talking in terms of domain. So now that that's cleared up, let's get into the problem. So we're looking for some type of function. We want to know f of x is going to be equal to, so let's change that color. We're going to be saying that f of x is equal to something. And for this specific problem, we're going to have three parts, right? We have a blue section, a red section, and a green section. All right, so let's get into that. One of the most reliable ways is using a point and the slope to find a, use that to get slope intercept form. Sorry, can't find my words here. If you have any point and the slope, you can use y equals mxb, and then you can figure out what the rest of the information that you need is. First, I want to look at my domain. All right, those are generally the easiest ones. The domain for segment A, right, we're looking at x values, our intervals. It's going to start right here. So it's going to be -2. There's a closed circle, so we're going to put the less than or equal sign and then x, and it goes up to this point right here. So that's going to go up to 1. Open circle means it's just going to be less than 1. So my domain for the segment A, the blue one, would be -2 is less than or equal to x, which is less than 1. After I know that, that's when I'm then going to pick a point on the graph, any point you want, it doesn't matter which one. 1, -1 is already labeled, so I'm just going to use that. And we want to also write what the slope is. Now the slope, easiest way to find that is to count. Do be careful. Notice that our grid is by 2s, not by 1s. So make sure you are careful while you're counting. Now, if I look at this here, my best bet to count the slope would be to go from here up here, because I know the exact points. So this goes up 6 spots, and it goes over 2. So my rise would be 6 over 2. 6 over 2 is going to reduce to 3. So my slope for this problem is 3. You'll get the hang of that pretty quickly, and we'll have 2 more examples, so you'll get the idea there. Once you have a point and a slope, what you then would do is you would plug that into y equals mx plus b. Is this the only method? No, but in terms of linear functions, these are all linear, it's the most reliable one. So my y value would be -1, right? We're using this point here. M is my slope. I know that that's 3. X would be 1. And I'm trying to figure out what b is. So just solve for b. So this would be 3 plus b, subtract 3, and b would be equal to -4, which makes sense because if I look at my graph, I notice that my y-intercept is -4. Sometimes it'll be incredibly easy to figure that out, and you won't even actually need to calculate everything, but the linear functions don't always cross the y-intercept, so you do want to be careful with that. So f of x will be equal to m, which is 3. We're going to say 3x minus 4. And then we can take this and plug it into our answer. So we're here, we're going to say 3x minus 4, and that is for all points from -2 less than or equal to x less than 1. So it's my domain and my function. So we figured out that first blue section. Next, we're going to look at segment B. Again, we'll start with the domain. So my domain will be right here. So it's going to start at 1. Closed circle, so less than or equal to. And then it goes up to 5. Closed circle, so less than or equal to. Let's put some extra dotted lines here to separate this a little bit. Okay. Oh, pick a point. Again, you can choose any point there. I'm just going to select 1, 4 because it's already labeled. And then figuring out the slope. Well, my slope, find some coordinate points. This isn't as easy, but let's go here. Let's go up here and then over to this point. So that goes up 2 and goes to the right. So that's going from 1 to 3. It also goes over 2. So my slope would be 1, 2 over 2, right? That reduces. So let's erase that so we don't get confused. And now we plug everything into y equals mx plus b. This is one where maybe you could figure out just looking at it. You also could have done that with segment A, but I want to show the process behind it. So if you can't figure out what the equation is just looking at the graph, you know what method to follow. So y is going to be 4, m is 1, x is 1, and b is what we're trying to solve for. So just a reminder that I'm using these points 1, 4, and 1, and those are getting plugged in as my mx and y. So let's solve this. 4 is equal to 1 plus b, subtract 1, so 3 is equal to b in my equation. So f of x would be equal to the slope 1x, or just x, plus 3. So let's plug that into our function, our answer up top. So we'd say x plus 3. And that's for the domain of 1 less than or equal to x less than or equal to 5. So that whole piece comes from here and here. All right, and then finally, let's find this last piece. This one's kind of easy. We have a flat line, right? There's no slope, but we'll do everything we need to anyway. So our domain, that starts right here. It starts at 5. Now, in this case, the circle, the closed circle there is red, not green. So if we're there, we would apply that's part of segment B. So think of it as an open circle for the green. And then that goes up to 8. So that would be a closed circle, so it'd be less than or equal to. Okay, let's continue right on. We have our domain now. We can pick any point we want. The 0.58 is on there, right? It's in red, but it's also for both. So we'll use that. I always like to use points that are already labeled. It limits my mistakes. And then the slope, well, it's a flat line, right? There's no rise, so the slope would be 0. Y equals mx plus b. Y is going to be 8. M is 0. X is 5. And we're going to add b to that. So 8 equals 0 plus b. So b equals 8, which makes sense, right? Because our line is going to just keep crossing or keep going. So we'll write that out. So f of x would be equal to, the slope is 0, so we can say 0x plus 8, but we're better off just saying f of x is equal to 8. So we have 8 here, and that goes from a domain of 5 less than x, which is less than or equal to 8. And that's it. We've come up with a piecewise defined function that is shown in the graph. Now remember, there are other ways to come up with these equations. And we're dealing with linear functions here, so sticking to slope-intercept is the most reliable method. If you had a quadratic, there's going to be a lot more work there. For this section, you're always going to be given linear pieces. All right, so if they're asking for the function, it's going to stick to linear ones. And if you look at the try-it ones, you'll see that all 3 of the lines in each section are linear. So don't worry too much about a quadratic for these type of problems. But using this method is, I mentioned it, is the most reliable way. There are times where you're going to be able to look at this, let's say in this case this one, and you'll know what the slope is, and you'll know what the y-intercept is without having to do any other work. It's not always going to be the case, but at times it will be. So if you can cut some of that out, feel free to. Make sure you explain, your reasoning and what you're actually doing. But this method, doing it piece by piece, will be reliable, and you can stick to the slope-intercept method for finding your functions, your piecewise defined function.